Hey everyone, and welcome to this explainer. I am absolutely thrilled you're here with us today because honestly, we're looking at something that feels like it's straight out of a sci-fi movie, but it's literally unfolding right in front of us. We are witnessing the geopolitical clash of the century. It's a high-stakes race between two technological superpowers to build the $10 trillion workforce of tomorrow. I mean, think about that. Elon Musk actually believes humanoid robots will eventually be worth more than Tesla's entire car business combined. Crazy, right? Meanwhile, across the globe, incredibly advanced robots are already shipping out to labs and developers today. So today, we're going to cut through all the noise. We're looking at the raw data, the hidden financial margins, and the underlying engineering philosophies of two of the most talked about machines on Earth, the Tesla Optimus and the Unitree G1. Okay, let's dive into this. If you watch the promotional material online, you know the hype is absolutely deafening. On one hand, you have Tesla, showing off these sleek, autonomous bots smoothly folding laundry. And then you have Unitree, showcasing their machines executing synchronized martial arts and taking these heavy, brutal kicks without even falling over. But let's strip away the Silicon Valley marketing and those flashy acrobatic stunts for a second. What actually happens when these machines hit the chaotic, totally unpredictable factory floors? Or, eventually, maybe even your living room? The stakes of this automated rivalry are absolutely massive, and survival out in the real world, well, that comes down to three things: physics, software, and economics. To truly understand this showdown, here's our roadmap for today's explainer. We're going to systematically break down this rivalry into four parts: muscle and mechanics, the battle for robot brains, the price of automation, and finally, the final verdict. But before we even look at the hardware, we need to quickly understand the core, fundamental problem that both of these companies are desperately trying to solve. And that core problem is defined by this completely mind-bending rule in robotics known as Moravec's paradox. Basically, this is the principle that for an artificial intelligence, high-level reasoning, like, say, calculating complex math trajectories or beating a grandmaster at chess, is actually mathematically cheap and super easy. But those unconscious human skills we take for granted, things like dynamically catching a ball, balancing on one foot, or just adapting to a toddler spilling milk all over the floor, those require extreme mechanical genius and just massive, massive computational power. Engineering the physical bodies and the spatial awareness of these machines is quite literally a monumental challenge. It's like a giant puzzle. So how are these two giants solving that physical puzzle? That brings us to Section 1, Muscle and Mechanics. When you sit down to design a robot that has to navigate a world built for humans, you have to ask yourself a key question. Are you building a highly agile gymnast, or are you building a heavy-duty worker? Now, what's really interesting about this slide is just the sheer physical contrast between the two. Just look at the tail of the tape here. Over on the left, Tesla's Optimus is built basically at a human scale. It's 1.73 meters tall and weighs in at a pretty hefty 57 kilograms. It's explicitly designed to lift heavy things, boasting a speculated payload capacity of around 20 kilograms. It's built to operate naturally in environments that were already built for adult humans. Then, on the right side, Unitree's G1 is incredibly compact. I mean, it's only 1.27 meters tall and weighs just 35 kilograms. It's hypermobile, sure, but that single-arm payload is a measly 3 kilograms. So right off the bat, you can see it's a sprinter, not a weightlifter. Let's look a little closer at the gymnast of our story, the Unitree G1. Unitree takes this highly efficient, really physics-based approach. They literally cram the motors directly inside the hand itself. Now that gives incredible transmission efficiency, but it does create a heavier wrist. This machine boasts up to 43 degrees of freedom. That is wild. It gives it that explosive power, extreme dynamic balance, and the ability to do those martial arts stances or quickly recover from falls. However, that explosive agility absolutely comes at a cost. Out of the box, it features a stiffer, modular 3-finger hand, and its battery runtime is currently limited to just about 2 hours. Though importantly, that battery is quickly swappable so they can get right back in the game. On the exact opposite end of the spectrum, we have the surgeon, Tesla Optimus. Tesla went with a high-risk, high-reward biological design. They actually use tendon-driven mechanics. So the heavy motors sit way back up in the forearm, and they pull the fingers via high-tension cables. It's just like human muscles. Actually, it's beautifully elegant because it leaves the hand itself ultra-light, which makes room for these advanced tactile sensors and 22 degrees of freedom. That's what allows Optimus to gently hold a fragile egg without crushing it. So Tesla is prioritizing absolute heavy-duty stability over raw speed. And for factory owners, well, the real standout feature is its massive 2.3 kilowatt-hour battery that's designed to push up to 8 hours of stamina on a single charge. But, as we know, a fancy body is completely useless without a brain. So let's jump into Section 2, the battle for robot brains. Because a cheap, highly articulated robot is basically just a shiny metal toy if it lacks the intelligence to navigate a messy, chaotic, real-world environment. So the crucial point is how these robots actually perceive the world around them. And they are completely divided here. Tesla adopts a super bold camera-only perception strategy. No expensive laser scanning towers, no extra hardware, just vision. They feed video from multiple cameras directly into neural networks, attempting to see the world exactly the way you and I do. Unitree, on the other hand, embraces a more classical, tried-and-true robotics stack. They use a combination of 3D LiDAR for really precise spatial mapping, alongside depth cameras and joint sensors. It's a sensor fusion approach that is highly reliable, especially in low light or visually complex environments. And that makes it incredibly attractive for researchers who just want precise, reproducible data without any guesswork. Let's move to and see how this builds into Tesla's ultimate software advantage. Tesla is playing a completely planetary scale game here. Optimus runs on the exact same end-to-end neural network architecture as Tesla's full self-driving cars, digesting literally billions of miles of real-world video data. The training setup is fascinating. It works like this. First, a human performs a task in virtual reality. Then, the AI takes that data and practices the task millions of times inside a digital simulator. Finally, through what is essentially a giant hive mind, if one single Optimus learns how to pick up a slippery battery today, that knowledge can be instantly deployed to every single Optimus robot on Earth tomorrow. It's just brute force data at a massive scale. Which brings us to Section 3, the price of automation. Because at the end of the day, all this fancy physics and cutting-edge software means absolutely nothing if the return on investment doesn't actually make sense for the buyer. I want you to imagine you're a factory owner looking to automate your floor. $20,000. That is Elon Musk's super ambitious long-term price target for the Optimus once they hit a manufacturing scale of millions of units a year. Tesla plans to achieve this through extreme vertical integration. Remember, Optimus is essentially just a Tesla vehicle working on legs. It uses the exact same FSD computer, the same vision cameras, and the exact same battery tech. By sharing this massive hardware library with millions of electric cars on the road, they plan to squeeze out costs and make this machine highly affordable. But keep in mind, this is still very much a future target. $16,000. Now, that is not a future target. That is the immediate, real-world, swipe your credit card starting price of the Unitree G1 today. When Unitree launched the G1 at this price point, it completely sent shockwaves through the entire robotics industry. I mean, before this, humanoid robots were luxury research tools that would easily cost you $80,000 to $100,000. But by utilizing Shenzhen's rapid prototyping and their just massive supply chain ecosystem, Unitree absolutely collapsed the barrier to entry. They've made these robots incredibly tempting and accessible to labs, universities, and early commercial adopters right now. And this brilliantly illustrates the hidden weapon in Unitree's arsenal. Deep inside Unitree's pre-IPO prospectus, which is a legally binding financial document, by the way, sits this staggering detail. Unitree is currently operating with a gross profit margin of over 62%. Now, why does that matter to us? Because that 62% is pure ammunition. It means that when the real commercial price war inevitably begins, Unitree has a massive financial buffer. They can slash their prices even further and still survive, making them an incredibly formidable competitor against absolutely any Silicon Valley giant. All right, let's wrap this up with Section 4, the final verdict. We've looked at the biology, we've looked at the brains, and we've checked the bank accounts. We have two very different robots built for two very different realities. Looking at this comparison, the philosophical divide becomes perfectly clear. Tesla is basically operating like Apple. They're building a closed, tightly controlled ecosystem focused heavily on scalable AI, massive manufacturing, and ultimate labor replacement. But currently, Optimus is really mostly restricted to internal factory testing. Unitree, on the flip side, is operating much more like Android. It's an open, highly accessible platform focused on agility and providing developer tools so others can build on it. And they are happily shipping to labs worldwide today. Tesla is trying to win the future of autonomous capability at a massive scale, while Unitree is successfully winning the present by getting real, physical hardware into people's hands immediately. And that leaves us with one final profound question to think about. As we stand right here on the precipice of this completely new industrial revolution, what's your move? Do you bet on the present, an agile, affordable platform that is ready to be programmed and pushed to its limits today? Or do you bet on the future? A heavyweight, highly intelligent machine that promises to learn, adapt, and eventually conquer the human world all on its own. It is a fascinating divide, and honestly, the outcome of this race will fundamentally reshape how we all live and work. Thank you so much for joining me on this explainer today. I really hope it sparked your curiosity as much as it did mine. Keep learning, keep questioning, and I'll see you next time.